Hello and welcome to today's screencast. Focus is going to be on gaseous exchange. So if we have a quick look through where we've been so far, the respiratory system, we've had a look at our lung volumes, particularly breathing frequency, tidal volume, minute ventilation. We've looked at definitions, values at rest. We've had a look at how they change during different intensities of exercise. On top of that, we've had a look at the mechanics within our respiratory system, the mechanics of breathing, and how they allow us to take in air via inspiration and then remove air via expiration. The final topic comes under something called gaseous exchange. So once we've got air in, we then need to see how we can get the gases that we want, oxygen, to our working muscles, and how we can get the gases we don't want, e.g. the carbon dioxide, from our muscles and then out, okay, and breathe it out. So that's what we're going to have a look at today, gaseous exchange. So just to get started, if we have a quick look onto here then, what we have to do, we are looking at how we can move gases, particularly oxygen, from our lungs or the alveoli into our blood and then to our muscles. We're looking at how we can get CO2 from our blood to the alveoli. So from our muscles to the blood and then to the alveoli. Okay, so we can breathe it out. I'll go through that in more detail. This is the keynote. Don't draw this, okay, because you'll get a chance to draw it later. Gaseous exchange at rest. This will be a good thing to just make a start point on what do you need to know about gaseous exchange at rest. These are the key things. Two gases we're interested in today, oxygen and carbon dioxide. There are two sites or areas at which gaseous exchange takes place. Okay, so we have to look at how gaseous exchange between the alveoli, you might know this as lungs, and blood. And we also have to have a look at how gases exchange between the blood and the muscles. Okay, and then final thing we need to have an understanding of, this whole process of gaseous exchange takes place via a process called diffusion. And diffusion refers to where gases move from an area where they're high pressure or partial pressure, as we have to call it, to low partial pressure. So we'll have a look at this in a little bit more detail now as we go on to the next slide. So let's just have a real basic understanding of this. So what we are interested in, I said we're interested in two gases. So I'm going to show you individually how each gas moves through the respiratory system via gaseous exchange. Now you do not need to write anything here. We'll be going through it in a little bit more detail on the next coming slides. So just to give you a basic idea of where we are going with this. So if I say to you at this point, so imagine you are going to breathe in air. So you're breathing in oxygen. Okay, oxygen then goes down into our lungs via the alveoli. And once we get it into our alveoli, it is then high there. Now, because it's high there, we then need to move it to where we need it. So we'll then move it into our blood. So it'll go down in a process from there to there. Then we need to get it from our blood to our muscles. Okay, so that allows us then to have oxygenated blood into our muscles. Okay, and we can then work for longer before fatigue. On the flip side to that, the gas we are also interested in is carbon dioxide, and for different reasons, because that is a gas we don't really need, or it's something that can be quite harmful in terms of exercise. So let's have a look at how that would work. So we've got a high amount of carbon dioxide in our muscles because the oxygen is used up to allow us to carry out our kind of resting functions. So there's a high amount, or partial pressure as we'll call it, of carbon dioxide in the muscles, so we need to get that into the blood. As you know, that's deoxygenated blood there. So then we need to get that into our lungs so that we can then breathe it out. Okay, so that's the process. What we're going to do now is we're going to zoom in a little bit more, I suppose, intricately to see how we answer questions on this. So first thing we're going to look at then is gaseous exchange at rest, and we're going to look at site number 1, which is going to be between the alveoli and blood. So this is our alveoli, this is the blood here that comes all the way around to here. So we're looking at how we get oxygen from here to here, okay, and let it come to there. We're looking at how we get CO2 from here to here, so we can breathe it out. That's our focus, alveoli and blood. That is our first section. Let's have a look at how it works. So we've got a high partial pressure of oxygen in the alveoli because we've just breathed in that gulp of air. Okay, so we've got a high partial pressure of oxygen in the alveoli. Now, what we have to know from there then, if there is a high partial pressure of oxygen, only one gas can be high in the same site. So, because of this, this means there's a low partial pressure of carbon dioxide in the alveoli. On the flip side, because we know the blood that is coming back towards the alveoli or the lungs, okay, we know this is deoxygenated, so that will tell us that there is a low PPO2 in the blood, partial pressure of oxygen, and there is a high partial pressure of CO2. Okay, now what this causes is diffusion gradients. Now, diffusion gradients are the difference between a high and low pressure of a gas. So in this case, there is a high partial pressure of oxygen in the alveoli. There is a low partial pressure of oxygen in the blood because it's deoxygenated. This creates a oxygen diffusion gradient, and this then causes oxygen to move into the blood and then go all the way around here, which we'll look at in the next slide. On the flip side to that, because there is a high partial pressure of carbon dioxide here and in the blood and a low partial pressure of carbon dioxide in the alveoli, this creates a carbon dioxide diffusion gradient. So carbon dioxide diffuses from where it's high pressure in the blood to where it's low pressure in the alveoli. Now, you do not need to write that. You don't need to put all that down. What I'm going to do now is, now you've seen it in action, you can pause it, rewind, have another little look at it. What I'm going to do now is put this into how you might answer it in an exam question. So when we're answering an exam question on this, between the gaseous exchange between the alveoli and the blood, we need to know how it happens. Now, I've just shown you that, but you might be thinking, right, how do I actually write that? So what I'm going to do now is show you how that would work. Okay, so first thing we always start, how do we diffuse gases between the alveoli and blood? Well, we do it via diffusion. Diffusion is where gases move from an area of high partial pressure to low partial pressure. So in this case, we'll start off with oxygen. So that's our first gas we'll have a look at. We know there was a high ppO2 in the alveoli and a low ppO2 in the blood because it was deoxygenated. Okay, this creates an oxygen diffusion gradient, which causes oxygen to move from where it was high, the alveoli, to where it was low in the blood. Okay, on the other side, we had carbon dioxide working at the same time, simultaneously, but we'll split up our answer to make it easier and more logical to structure. Okay, so from there, we had a high ppCO2 in the blood because it was deoxygenated, had no oxygen, so it had more carbon dioxide. There's a low ppCO2 in the alveoli. This creates a carbon dioxide diffusion gradient, so our carbon dioxide goes from where it was high in the blood to where it's low in the alveoli. And that is our first section complete. Okay, so if we move on from there then, let's have a look at how this works in between the blood and muscle. So we've looked at alveoli and blood. Now what we know is that we have diffused oxygen into our blood from the alveoli. So now what we have to do is have a look at what happens down here. Okay, so now we've got the oxygen here. It's going to be high because we've got it in from here, and we need to get it into there. On the flip side to that, we know that our muscles tend to use up all the oxygen, so this means that there's not much left, therefore there's a high carbon dioxide. Let's have a look at how we would write this. So there is a high ppO2 in the blood. Because that's high there, it means that automatically the other gas is low, so there's a low ppCO2. Now hopefully people understand there's a high ppO2 because it's just oxygen has just been diffused from the alveoli into the blood. That is why it is high. On the flip side to that, okay, there is a high ppCO2 in the muscle because oxygen has been used up, therefore the partial pressure of carbon dioxide rises. And there is a low ppO2 in the muscle. Okay, so that should make sense to people because it's used up to allow us to survive, I suppose, to keep our daily functions alive. So if that's our situation, we should now be able to see that there are differences. There's a diffusion gradient, well, there's two diffusion gradients created because there's a high ppO2 there, a low ppO2 there. So what does that mean? We know that's called an oxygen diffusion gradient. So oxygen moves from the blood into the muscle. Okay, on the flip side to that, we also know that there is a high ppCO2 in the muscle and there's a low ppCO2 in the blood. So that creates a carbon dioxide diffusion gradient, which means that carbon dioxide moves from the muscle into the blood. And that allows us to take it back round here and start the whole process again between the alveoli and blood. So let's have a look at how we would write that. Okay, so now we go into our blood and muscles. This is your title. Let's have a look at how this might work. So between the blood and the muscles, how does it happen? Okay, well, we know, always the same, starts with diffusion. Okay, gases move from an area of high partial pressure to low partial pressure. So we always have to get that bit in. So now we need to split our gases up again. So if we start off, because we know it's between the blood and the muscles, let's have a look at oxygen. So there's a high ppO2 in the blood, low ppO2 in the muscles. That causes an oxygen diffusion gradient, which causes oxygen to diffuse from the blood into our muscles, which allows us to exercise. The flip side to that, we now need to talk about how we remove carbon dioxide from the muscles. Okay, so we know where there's a high ppCO2 in the muscles, there's a low ppCO2 in the blood. That creates a carbon dioxide diffusion gradient, the difference between high and low. Okay, and this then causes CO2 to diffuse from our muscles into our blood so that we can then move on from there. Okay, so can I ask you to make good note? You might need to pause this and go back through it. Okay, in the lesson, I will show you some ways to remember and to make sure you've got an answer framework. But it's really important you have a couple of listens to this and then ensure that you create really good questions that are itemizing your knowledge. Okay, that really makes it easy for you to recall that. Okay, thank you.